Hello, in this video we will look at negative exponents. So if you remember from the quotient rule, the negative exponents happen when you have more factors in denominator. For example, if we have x to the second out of x to the 5, using the quotient rule, this will give us x to the 2 minus 5, and we would get x to the negative 3 as a solution. However, if we rewrite these exponents and get x to the second as x times x, and x to the fifth as 5 factors of x in denominator, so we get 2x's in numerator and denominator cancel into 1, and this whole fraction will become 1 out of 3 factors of x in denominator, so x to the 3 in denominator. So to rewrite k to the negative fourth with positive exponent, all we have to do is just send it into denominator and have 1 out of k to the fourth. And the whole number is always in numerator because you can write it out of 1 anytime you need. So what happens if the negative exponent is in denominator? Here we have 1 out of m to the negative second. Let's deal with the negative exponent in denominator first. So we have 1 out of, and to change m to the negative 2 into something with a positive exponent, all we have to do is divide 1 by m to the second. This will make m to the negative 2 positive. To simplify this complex fraction, we can take 1 from numerator divided by the fraction in denominator, so 1 out of m to the second. To divide by a fraction, we keep first item as is, so we have 1. We change division into multiplication and flip the second fraction, so we get m to the second out of 1. M to the second times 1 divided by 1, this just simplifies into m to the second. So if you have negative exponent, it will become positive if you move it into numerator. And the whole number is in numerator because anything can be written as out of 1. So if you have a big fraction that includes a lot of negative signs, you don't really want to write it out the long way and perform division or cancellation. Here we have a fraction of 2x to the third, y to the negative second, z to the seventh, divided by 3, a to the negative fourth, b to the sixth, c to the negative 27. And a very easy way of simplifying this fraction is to look for negative exponents. So in numerator we have y to the negative second that has negative exponent. In denominator we have a to the negative fourth and c to the negative 27th. And these exponents will become positive if you move them across the division sign. So 2 has a positive 1 as the exponent and 3 has a positive 1 exponent as well. Those are the identity exponents. 2/3 will stay as is, so we have out of the division sign 2/3. X to the 3 will stay the same. Z to the 7th will stay as is. In denominator, b to the 6th will stay as is, because those are the numbers and variables that had positive exponents. Y to the negative second will become positive in denominator, so we have y to the positive 2 in denominator. A to the negative fourth will become a variable with positive exponent in numerator, so a to the fourth in numerator. C to the negative 27 will become a variable with positive exponent in numerator as well, so we get c to the positive 27 in numerator. This is a perfectly fine solution. However, some answer keys list variables in alphabetical order, so we can have 2a to the fourth, c to the 27, x3, z7 out of 3b to the sixth, y to the second in denominator, and this is also a good solution. That's all.